Hi everyone, and welcome to week 5, class 2, arbitrage pricing theory and market efficiency. Okay, so this week's tutorial has a lot of theoretical components as well, just like the lecture notes. So sit back and try to understand the concepts behind arbitrage pricing theory, market efficiency, and we will cover a little bit, hopefully, of behavioral finance. Okay, so basically, what happens, we're going to look through class 2, we're going to look at chapter 7 and chapter 8. And as usual, what happens is that usually during the tutorials and laboratories, I usually try to make them interactive. I try to ask you guys to talk about the potential solutions, the answers, or have a discussion theoretically. So that's where we actually use up quite a fair bit of tutorial time to have a discussion because it's a video that's a little bit more difficult. So I'll talk about each question and explain the solution myself. So basically, that is the reason why that the class 2 recording might not go on for the full 2 hours, put it that way. So what happens, I'll be covering a broad range of questions and having the solutions. And what I do hope is that all of you do try to work on the questions yourselves, especially on the quiz. And I also brought up to all of you to actually try looking at the Sharpen app. Okay, Sharpen app for essentials of investments. Okay, so I just found this resource, and it's by the publisher of the textbook, and it's freely available. Okay, so you can go see all titles, and you can go into finance and essentials of investments. So there you go. So what happens over here is that it's got additional quizzes, video lessons, practice problems, chapter summaries, flashcards, and more. So it's broken them up into different chapters. I really, really encourage you guys to download this. I've had a try of it, download on my phone, and it's just a really, really good resource because you don't want to wait until the day or the days before the mid semester, the exam, to start to practice your learning. You just want to get started now. So it's good to sort of like keep practicing, keep learning day after day by doing some flashcards, practice problems, tracking your progress, looking through the quizzes. So really, really, really do please look at getting the Sharpen app. All right, without further ado, let's start with chapter 7, question 8. Okay. So which of the following statements is true? Is it possible that the APT is valid and the CAPM is not? Is it possible that CAPM is valid and the APT is not? Okay, now, when we actually did discussion about the CAPM APT, one thing that most of you recall is the fact that the actual CAPM has a lot of restricting assumptions. It's a lot stricter than the APT, right? And what happens, the arbitrage pricing theory actually allows for a lot more flexibility in the amount of factors you can include in your asset pricing model. Okay, so in a sense, if it was the arbitrage pricing theory looked at it from the perspective as being a single factor model and that factor being the market, then it would be pretty much the CAPM. Okay, so what happens is that like the APT can exist without the CAPM, but not the other way. Okay, so what happens? The statement that it is possible that APT is valid and the CAPM is not is possible, but not B, that the CAPM is valid and the APT is not. Okay, because ultimately the APT accepts the principle of risk and return, which is central to the CAPM, without making any assumptions regarding individual investors in their portfolios. However, these assumptions are necessary to CAPM. So as we mentioned before, CAPM has much, much stronger underlying assumptions CAPM actually also assumes that the only type of risk is systematic risk or market risk, whereas APT allows for different types of risks and risk factors. Okay, so basically, um, statement A is possible, but not B. Okay, so APT is actually a broader theory that includes the CAPM, but CAPM doesn't include APT because CAPM has much stronger assumptions. One of which is that like has a lot of assumptions about individual investors in their portfolios and assumes that the market portfolio is the the only risk factor there is out there. Okay, so that's question 8. Now let's look at 30 and 32. Okay, if APT is to be a useful theory, the number of systematic factors in the economy must be small. Why? Okay, so remember in the APT, we talked about the fact that we can have as many factors as possible, right? But if we had hundreds of factors, this would probably be a little bit unwieldy and probably difficult to use in practice. But it's not to say that this is not uh, possible, right? So when you think about it, any pattern returns can be explained if we can choose an indefinitely large number of explanatory variables. So CAPM essentially just uses one, which is the market portfolio, but APT says you can use as many as you need. Okay, so if I use thousands, of course I can explain anything, right? But if I want something to be pragmatic, practical, and useful, the number of systematic factors has to be reasonably small, right? So basically I can run a regression, I can look at the coefficients, okay? I can actually see what risk factors really influence the price of the asset. Okay, so there must be a reasonable limited number of explanatory factors or systematic factors if APT is going to be a useful theory. All right, so now let's look at question 32. Okay, now in this case, we have two factors identified for the US economy: the growth rate of industrial production, IP, and the inflation rate, IR. IP is expected to be 4%, IR 6%. A stock with beta of 1 at IP and 0.4 in IR is expected to provide a rate of return of 14%. If industrial production actually grows by 5%, what the inflation rate turns out to be 7%. What is your best guess for the rate of return on the stock? Okay, so instead of using just the cap and the market portfolio, we've identified there are two different risk factors. So let's try working this one out. Okay, I'm going to zoom in, I'm going to put all the information here, and we have the industrial production, IP, and we have inflation rate, IR. Okay, so okay. So over here, IP is expected to be 4%, IR 6%, stock with beta, okay, and let's see, is 1 and 0, oops, 0.4, take that off, just, okay. And so growth is actually 5% and it is 7%. All right. So what we actually have over here, okay, is that we have to have like what is the return? What is the rate of return of the stock? Okay. So the formula of this is actually really going to be the old estimate plus the sum of unexpected changes in the factors multiplied by sensitivity to coefficients. Okay. So basically what happens is that we have um, beta IP multiplied by, okay, so what happens, we're saying the rate of return is the old estimate plus the sum of unexpected changes in the factors multiplied by sensitivities to the coefficients. Okay, so let's look and see. Let's read it again. Okay, so two factors identified for the use economy, growth rate of the industrial production and the inflation rate. So we have that here. IP is expected to be 4%. We have that. IR is 6%. A stock with beta of 1. Okay, this is wrong. It should have been 1. And 0.4 in IR is expected to provide a rate of return of 14%. So expected return of stock is 14%. Okay, so what happens is that if the industrial production actually grows by 5%, what the inflation rate turns out to be 7%, what is your best guess for the return on stock? Okay, so the rate of return on stock is the old estimate. Okay, so the old estimate, which is the old expected return, is really 14%. Okay, because this is what it originally was. Now, what we're actually saying over here is that we know these are the beat-ins, but what we're saying is that originally IP was expected to be 4%, R was expected to be 6%, but this is actually what it actually grows by. Okay, so therefore it's a sum of unexpected changes, which really means it's going to be 5% minus 1%. And okay, so because the old estimate was 14%, right? But now we've said that, okay, what happens is that the growth rates were actually larger than expected. So basically what happens is that we can actually find out what the changes to the expected return by looking at unexpected changes times by beta. Okay, so that means is that factor-driven returns are going to be 1 multiplied by the unexpected change, and then plus okay, so just make it a little bit clearer, we'll just add the brackets here. So what we actually see is that we have beta of IP multiplied by expectation IP, beta of IR multiplied by unexpected change in IR. And there we have it. We have this answer over here. Okay, so we just add them both. Rate of return equals to, and it's 15.4% is the answer. Okay, so let's go on to chapter 8.